Hello, I'm Graham Horton and welcome to today's video. A little change from my usual photographic tutorials, etc. Going to look at a problem I've got which has been annoying me for several years. Around our garden I use quite a few of these floodlights to illuminate bushes and trees, and they fail with monotonous regularity, not because of water ingress, just because the LED chips are destroyed. You can see on the desktop here one of those devices which was a 30-watt floodlight, and you can see here the array of LEDs. This one is extremely exploded and the others have got a black dot in them, meaning they've been overcooked. These things run super hot and are being overdriven. Most of these devices have some sort of a cooling fin structure on the back, but it's debatable whether the actual substrate that the LEDs are mounted on actually makes contact with the case itself. So inevitably, after a short period of time, these fail, and okay, they're only about £10 a floodlight, but it's the inconvenience of having to go out there and rewire a new one in. So I thought about, well, why don't we reduce the voltage to these? And if we reduce the voltage, we reduce the current through the LEDs. That gives me two things. It gives me a longer lifespan, so I'm not overdriving the LEDs. The housing doesn't run as hot. We're also reducing the wattage, so we're actually reducing the cost. So over a year period, we're probably saving 50% on the cost of lighting in the garden. To do that, I'm using what's known as a capacitive dropper, and these things we can see in all sorts of parts. Now on the desktop here I've got a couple of capacitors. Both are X2 rated, but you can get Y2 as well. They're special capacitors designed for working on AC voltage. This one in particular is 1.5 microfarads and will withstand 275 volts AC. So typically you were running it on 250 volts AC in the UK, or harmonized now at 240 volts. This one here is the one that I'll be using, is a 1 microfarad. Again, it's a 275 volt AC working capacitor, and as we'll see, we're not actually going to be using that full working range when we employ these. So to achieve this voltage drop circuit, I've incorporated the capacitor into the circuit and I put it in a small box. So inside this box will be the capacitor and also a bleed resistor, so that if I unplug this, the bleed resistor will take away the charge in the capacitor, just in case I open this and forget and the capacitor is still live, obviously with the thing disconnected. So that 1 mega ohm resistor bleeds the residual value of the voltage left on that capacitor if we unplug it when we're at the peak of a sine wave. So the capacitor I've chosen for these 10-watt floodlights has a value of 1 microfarad, and I put that in series with the existing LED light. So the existing LED light is a 240 volts AC, 10 watts. So normally, without this capacitor in there, that would give me a current of about 41 milliamps. If we work out the resistance of this device, and it won't be a pure resistance because there'll be other components inside here, but that equates to about 5.85 kilo ohms. So that gives us our 0.41 amps, which flows through this device. So with this circuit, we're going to put a 1 microfarad capacitor in series with the LED light. So this capacitor has what's called a capacitive reactance. So if you like, that's the resistance of this capacitor to the AC voltage. It's not like a DC circuit where the resistance is I equals V upon R. You have to calculate the R from a formula 1 over 2 pi FC to give you the reactance. I've done that, and that gives me a reactance of 3.18 kilo ohms at 50 hertz. So effectively this is a 3.18 kilo ohm resistor in series with this 5.85. So if we work out the new current, I, that will be the voltage divided by the total resistance of the circuit. So that's going to be 240 volts AC divided by the 3.18 of the capacitor plus the 5.85 of the LED. So that gives me 240 divided by 9003, gives me a new current of 0.26 amps, which will flow through this circuit. So here 0.026 amps will flow through the circuit now. The new power will be I squared R, and that equates to 3.9 watts. So instead of being 10 watts, this will now be approximately 4 watts. So we'll reduce the light output slightly, but we'll certainly reduce the amount of power being dissipated on those LEDs, and we'll also reduce the temperature of the housing. So this is the light, and I'm going to plug it into a power meter here. I couldn't find my bigger power meter, which has got a higher accuracy, but for the purposes of this, with 1 microfarad capacitor, we should see the new power. So you can see the LED is still very bright and is sufficient for illumination of my trees and plants. We can see that we're showing 4 watts, which is exactly as we calculated from the design specification, or 3.9. So that's why this is fluctuating between 3 and 4. It's actually nearer to 4 than 3, so that's the 4 watts. So the light is consuming 4 watts. Now if I wanted to increase the brightness, obviously I've got to increase the current through the LEDs. So if I change this value of capacitor, if I change this from 1 microfarad to 2 microfarads, then the resistance will drop to 1.6 kilo ohms. The current will then increase, and it will give me approximately 8 watts. So let me plug in this other floodlight. And this one has a 2 microfarad capacitor in my housing, so let me plug this one in. You see it's slightly brighter as we're now running with a higher current, and if you look at the power meter, you can see that that now shows 8 watts or 8 point something. It's flicking between 8 and 9 watts. So if you are going to try this project for your own purposes to reduce the voltage to your outside LED lights, make sure that you're using these X2 rated capacitors. First of all, make sure you put a bleed resistor, and that bleed resistor goes across the capacitor like so, and it's a 1 mega ohm, sort of 1/8 watt is fine, and that will dissipate any voltage on there. So when the AC is at peak, if you disconnect your supply, then you will have the peak voltage at this point, and you don't want that on your hands if you go inside the unit. So that 1 mega ohm will bleed away that resistance. So you can see here how I've connected the 2 capacitors in parallel to give me the 2 microfarads from 1 microfarad and that 1 mega ohm bleed resistor across the device. And then inside the boxes I've just used Wago connectors to connect the whole thing together. So I put the whole thing in a waterproof IP55 box with glands to take the cable in and out, so it's totally waterproof and I can use it outside without any problem. Obviously the whole external circuitry is backed up with an RCD, so if there's any problems with leakage, then the RCD will disconnect all the LED outside lighting. So again, common sense to use an RCD if you're working with electrical equipment outdoors. Well, that's it for this video. I hope you found it useful. If you're a new viewer and you like what you see here, why not hit that subscribe button and the bell notification icon, and then you'll be advised if I upload new videos to the channel, be those photographic or electronics for photographers, etc. So until the next video, thanks again for watching. Please take care, and I hope to see you all very, very soon. Goodbye for now.